My name is Dr. Alexander Jesmer. I'm the CEO of Forsta Varme Technologies. We are a group of scientists and engineers based in Canada. We develop proprietary hardware that we use in-house for measuring thermal conductivity of complex materials and physics models that go along with that for interpreting the data that can be used in simulations for development of thermal management applications. Some of the main takeaways, the things that we all talked about, were that the numbers that people use for their designs for thermal conductivity are incredibly important. And most companies here are trying to make materials that are more thermally conductive, and not only more thermally conductive, but that also have all the other properties that engineers want. So that's spreadability, non-degradation to temperature. They want them to be safe to use, as low filler percent as you can get. But to go along with those improvements in thermal conductivity is the data that goes along with that, that's actually used by the engineers in the designs. That's where Forsta Varme comes in, is supplying that data that's trustworthy and that explains why materials act the way they do instead of just how they act. Finding materials that can do that and finding materials that are well understood that can do that at the same time is the biggest difficulty. Knowing how the device is actually going to be used. We take that approach with our clients is every piece of data has a lineage of where it comes from and how it's going to be used. So understanding holistically everything that's going to go on is the biggest problem for engineers too. How is a customer actually going to use this thing? And is the thing you're designing for actually the important metric that moves the needle at the end of the day? Technology being developed that has the biggest impact on us is machine learning, artificial intelligence, super high compute applications from both a technology design standpoint and also from our customer standpoint. Everybody wants to be able to do more compute in a smaller package and then use that compute to design generatively new engineering solutions. And all of that, right, relies on data inputs for training those models. And so from all three sides, we're using machine learning, we're providing data for machine learning, and people that are then using that data are using machine learning for doing engineering. So breakthroughs that'll define the next generation of thermal systems are adaptive systems, right? We want things that don't always act in the exact same way. Maybe you have a battery pack that you want to have at a specific operating temperature. You want to get it to that operating temperature quickly, but then you want it to stay at that temperature and not get too hot. So having adaptive thermal conductivity materials or predictive models for determining how that battery is going to be used as it's being used by your customers, that all defines everything that we're designing now. We're preparing ourselves and our customers to compete with these new technologies because everything that I've mentioned so far, right, is all dependent on machine learning, AI, and computational design of making things more precise, more accurate, higher performance. And all of that relies on the data that you put into these models. It's like getting to fly an airplane with instruments instead of just by eye for an engineer with Forsta Varme's data. We chose to do Thermal Management Expo Europe because our products touch all along the thermal conductivity value chain, from raw materials makers, from like chemists to thermal management material formulators to OEMs at the end of the line that actually integrate those materials. And this is basically the only place where all of those people are in one room together, and we can bring up problems that suppliers have with their users, and everybody has the same conversation. Yeah, in the upcoming talk on Thursday, we're going to be talking about how we are supplementing existing thermal conductivity measurement data with our more advanced dynamic thermal conductivity, and then going beyond that by using machine learning so that you can take our models that we develop and essentially use them with anybody else's measurement hardware. So not only can you use our measurement hardware, but other companies, and then you can also use those models inside of your simulations to reduce the complexity of your simulations, but maintain the same accuracy. So I think it'll be an interesting talk. Thermal Management Expo Europe, in one sentence of the 2 hours that we've been here so far, is expertise and a mentality of all tackling the same problem.